Chapter 2, the technology infrastructure, the internet and the World Wide Web, is a really interesting chapter. I mean, this is what makes e-commerce and e-business work, so it's fascinating to see what it does, how it's evolved, and so on. So let's see. Let's start by getting out of this actually and looking at a few trends going on here. Here's a couple here. Obviously, mobile devices are exploding. There's something called the Internet of Things we'll get into. Cellular service is also emerging with the G5 and so on. But let's start with some trends here. Okay, so Cisco. Many of you have heard of Cisco. They're the preeminent network provider, and they are looking at trends in 2017. This is really interesting. So we'll get into WAN and LAN. WAN is wide area network, LAN is local area network. So the internet is the ultimate giant WAN, wide area network, and I'll get into what LANs and WANs are in a second. But anyway, we talked already about the cloud and how it's mature, but it just continues to grow, and more companies continue to use the wide area network and the ability to use cloud services and cloud infrastructure. So that's continuing to grow. Virtualization. This is where you use your computers and you segment it up into different sections so you can use them more efficiently. And let's see, I'm just going to try to go fast here. IoT, Internet of Things. I'll show you a little short video in a minute on what this is, but essentially, when you make all kinds of sensors embedded in different devices so they can communicate across the web, that's what the Internet of Things is. But this is interesting. Chief operating officers are beginning to see the value that IoT can bring to the workplace, like intelligent lighting, location services, connected AC systems, and so on. And I'll show you a video so that makes a little bit more sense, but IoT is getting to be huge. Software-defined networking, starting to sprout in wired and wireless environments. So essentially automation across the network, so intelligence that's tied into the Internet of Things. Let's see, machine learning. Again, all these things kind of build upon each other. Machine learning, artificial intelligence, connecting things, automating processes across the network, that continues to grow. Location-based services, we've talked about this already. Retail, healthcare, entertainment, hospitality. Again, in a prior lecture we talked about when you go in a store, the location-based services senses where you are, sends you automatically a coupon for that store, and so on. If you go into a healthcare facility, a location-based service can sense when you arrive, can maybe check you in automatically. All kinds of really interesting opportunities. Voice over Wi-Fi. They're talking about the idea of voice and natural language processing also kind of becoming a more common occurrence. Let's see. Let's just scroll down a little bit here. Yeah, okay. That's pretty much that. Let me go to the next one here. Again, this is a little short one, and it kind of reiterates what we just saw here. So IoT, huge and growing. This is interesting too, botnets. So one of the big problems with the Internet of Things is that there's been a lot of security vulnerabilities. Hackers have been able to get in to different devices. There was a classic story on the news about a babysitter where the parents had set up a smart baby monitor so they could check in and on their smartphones and see what the baby was doing and so on and so forth. But babysitter was there, and a hacker had gotten into the baby monitor, and the babysitter was like, here's this voice talking to her, and it's just very creepy. So hackers are getting into all kinds of Internet of Things devices, and that's kind of a scary thing. So that's security's ramping up around that. Network boundaries continue to blur as employees and their devices connect from work, home, and their via cloud-based, data-intensive. This is all enabled, of course, by a robust, intelligent network. So that's important, the internet. This is interesting. But the budgets, you would think that chief operating officers, chief information officers would request higher budgets because it's a competitive advantage if you can make your operations seamless and more increased productivity and so on. So that's actually a surprising trend here. Okay, so let me go back here. All right, Okay. I like this visual to kind of start off of that the internet allows us to live in an interconnected world, and so this is kind of just a visual to give you an idea of how the world is hugely connected in many ways. Okay, so let's start off with what is the internet. And I know you all know, of course I know what the internet is, but let me show you two quick little videos because we all think we know, but maybe there's some things that you may not know, or you may not understand exactly how it works. So I'm going to just show you these two little videos real quick.
What is the internet?
The internet is like a popular thing.
Some satellites up there.
I picture in my head with like waves of internet going to the phone.
Somebody told me a cloud once.
The internet is a lot like plumbing. It's always moving.
Most people don't have any idea where the internet came from, and it doesn't matter. They don't need to. It's sort of like asking who invented the ballpoint pen or the flush toilet or, the zipper. These are all things that we just use every day, and we don't even think about the fact that one day somebody invented them. So the internet is just like that. Many, many years ago, in the early 1970s, my partner Bob Kahn and I began working on the design of what we now call the internet. It was a result of another experiment called the ARPANET, which stood for Advanced Research Projects Agency Network. It was a Defense Department research project. Paul Barron was trying to figure out how to build a communication system that might actually survive a nuclear attack. So he had this idea of breaking messages up into blocks and sending them as fast as possible in every possible direction through the mesh network. So we built what eventually became a nationwide experimental packet network, and it worked. Is anybody in charge of the internet?
The government controls it.
Elves, obviously elves.
The people who control the Wi-Fi, because then no Wi-Fi, no internet. T-Mobile, Xfinity.
Bill Gates.
Bill Gates.
Bill Gates. Right?
The honest answer is, well, nobody, and maybe another answer is everybody. The real answer is that the internet is made up of an incredibly large number of independently operated networks. What's interesting about the system is that it's fully distributed. There's no central control that's deciding how packets are routed or where pieces of network are built or even who interconnects with whom. These are all business decisions that are made independently by the operators. They are all motivated to assure that there is end-to-end connectivity of every part of the network, because the utility of the net is that any device can communicate with any other device, just like you want to be able to make phone calls to any other telephone in the world. There's nothing like this that has ever been built before. The idea that what you know might be useful to somebody else or vice versa is a very powerful motivator for sharing information. By the way, that's how science gets done. People share information. So this is an opportunity for people to think up new applications, maybe program them as apps on a mobile phone, maybe become part of the continued growth of the infrastructure of the network to bring it to people who don't have access to it yet, or just make use of it on a day-to-day basis. You can't escape from contact with the internet, so why not get to know it and use it?
Okay. I like that video. And it does a really nice job explaining the origins, what it is, and so on. Let me just follow up really quick on how it works.
Ever wondered how the internet works? Say you want to stream your favorite show on your tablet. It seems so easy, but how does it just magically appear on your screen? First, you have to understand how we're all connected. No, it's not actually in the clouds. It's through millions of kilometers of cable crisscrossing the planet, linking computers to one another. For example, if you want to search for a movie on your favorite streaming service, that search term is broken down into pieces of data called packets. Think of them like a parcel in the mail. The packets are given a to and from address called an IP address. The packets pass over Wi-Fi to your modem, which then send it to your internet service provider, or ISP. The ISP then sends the packets out into the World Wide Web until it reaches the movie site server you're looking for. The packets are rearranged, The movie is found, and the process reverses itself. The movie is broken into packets. It travels from the movie server to their ISP. Their ISP sends it back across the world to your ISP. The movie is rearranged, and it's sent to your tablet to start watching. There are some factors that can affect a connection regardless of the service provider that we're always trying to improve. Being too far away from your Wi-Fi modem, having the signal pass through thick walls, or even a cable breaking somewhere along the signal route can cause disruptions in your connection. So the next time you hit play on your favorite show, think of the journey that file made on its way to your tablet. Learn more at tellus.my.
Okay, so hopefully that's starting to make a little bit of sense to you. All right. Actually, and I just want to point out there's a couple other here. This TED Talk is really good also, but it's a little bit longer, and then for the interest of time, I didn't want to show it, but you might want to take a look at it because TED Talks are always really good. Okay, so we talked about, and we'll come back to some things like protocols and the idea that about consistency in platforms and all different, using the same systems to make the internet and transmission of data seamless. But let me jump into the Internet of Things because I was saying that that's the huge trend right now. Actually, once again, I want to show you two quick videos that I think visually make it easier to understand what the Internet of Things is. So let me start with this one right here. Oops, maybe.
Internet of Things. Sounds interesting, but what does the Internet of Things actually mean? IoT is an evolution of mobile, home, and embedded applications that are being connected to the internet, integrating greater compute capabilities and using data analytics to extract meaningful information. Billions of devices will be connected to the internet, and soon, hundreds of billions of devices. As related devices connect with each other, they can become an intelligent system of systems. And when these intelligent devices and systems of systems share data over the cloud and analyze it, they can transform our businesses, our lives, and our world in countless ways. Whether it's improving medical outcomes, creating better products faster with lower development costs, making shopping more enjoyable, or optimizing energy generation and consumption. Here's an example of the big picture. Imagine an intelligent device such as a smart traffic camera. The camera can monitor the road for congestion, accidents, and weather conditions, and communicate that status to a gateway that combines it with data from other cameras, creating an intelligent citywide traffic system. Now, imagine that intelligent traffic system connected to other citywide transportation systems, which get data from their own intelligent devices, creating an ever larger intelligent system of systems. The really big possibilities come from analyzing the end-to-end data across that system of systems. For example, let's say the city's intelligent traffic system detects massive congestion due to an accident. That insight can be sent to the citywide transportation system, which can analyze the accident's impact on other city systems. Recognizing the accident is near the airport and 2 city schools, it could notify those systems so they can adjust flight and school schedules. It can also analyze and derive optimal routes around the accident and send those instructions to the city's digital signage system to guide drivers around the accident. And that's just one example of the potential benefits that can happen when intelligent devices share insight with other systems, forming ever-expanding systems of systems.
Okay, pretty cool, huh? Oops. All right, let me get rid of this one. Okay, so and of course, all of this is enabled by having a robust internet, the infrastructure that allows all of this data to be transmitted, and having these cool artificial intelligence systems to analyze all these things and send it to the right place. So let me just show you one more here on how it works.
The Internet of Things is changing much about the world we live in, from the way we drive to how we make purchases, and even how we get energy for our homes. Sophisticated sensors and chips are embedded in the physical things that surround us, each transmitting valuable data that lets us better understand how these things work and work together. But how exactly do all these devices share such large quantities of data? And how do we put that information to work? Whether we're improving the production of a factory, giving city residents real-time updates on where to park, or monitoring our personal health, it's the common Internet of Things platform that brings this diverse information together and provides the common language for the devices and apps to communicate with each other. The process starts with the devices themselves, which securely communicate with an Internet of Things platform. This platform integrates the data from many devices and applies analytics to share the most valuable data with applications that address industry-specific needs. Let's start with a simple example, a car. After taking a long road trip, Rebecca notices that her check engine light has come on. She knows that she needs to have her car looked at by a mechanic, but is not sure whether it's something minor or something that needs immediate attention. As it turns out, the sensor that triggered Rebecca's check engine light monitors the pressure in her brake line. This sensor is one of many monitoring processes throughout the car, which are constantly communicating with each other. A component in the car called the diagnostic bus gathers the data from all these sensors, then passes it to a gateway in the car. The gateway integrates and sorts the data from the sensors. This way, only the most relevant diagnostic information will be transmitted to the manufacturer's platform. But before sending this organized data, the car's gateway and platform must first register with each other and confirm a secure communication. The platform is constantly gathering and storing thousands of bits of information from Rebecca's car and hundreds of thousands of cars like hers, building an historical record in a secure database. The manufacturer has added rules and logic to the platform. So when Rebecca's car sends a signal that her brake fluid has dropped below a recommended level, the platform triggers an alert in her car. The manufacturer also uses the platform to create and manage applications that solve specific issues. In this case, the manufacturer can deploy an application on the platform called the Asset Management System. This application oversees all of their customers' cars on the road, as well as all the parts in their warehouses. It uses the data from Rebecca's car to offer her a potential appointment time to service her car, directions to the nearest certified dealer, and a coupon for the service. What's more, the app will ensure that Rebecca's brakes are covered under her warranty, that the correct replacement part is ordered, and then sent to the dealership so it is ready when she arrives. But the manufacturer's analysis does not stop there. They have also deployed a continuous engineering application that tracks not only Rebecca's car, but hundreds of thousands of others, looking for ways to improve the design and manufacturing process of the car itself. If the same problem in her brake line crops up in a critical number of other cars, the manufacturer uses applications custom built for the automobile industry to pinpoint the exact problem. They can see if these cars were made at the same factory, used the same parts, or came off the assembly line on the same day. So what do all these pieces add up to? Streamlined inventory management for the dealer, a better, safer car from the manufacturer. And for Rebecca, it means she can be back on the road faster and get to where she's going safely. All thanks to the Internet of Things.
Okay. Again, I think all of that is just absolutely amazing. Now, one thing I want to mention, and we'll come to the very end of this talk, is that that all assumes a really high bandwidth internet connection everywhere. Notice how everything was going from her car wirelessly through the internet to the manufacturers and car dealers and so on. And so at the end of this, I'll show you the mains internet infrastructure, and you'll notice there's huge gaps where there's no coverage, and probably some of you have experienced that. But so that kind of also gives you an idea of why it's so important to have really good broadband connectivity for your business, for your home, and so on. Okay. I want to, as a last video for right now, I want to show you a video of the Internet of Everything. So the Internet of Things are all sensor-based systems working together to solve problems and so on. And then the next step in theory is what they call the Internet of Everything. And this video is a little bit longer than I usually like, but it's such a cool video where basically it just shows that in the Internet of Everything, our whole world is seamlessly connected. This is a futuristic video which you can see that Microsoft put on, so I think you're going to enjoy this. Pretty amazing, huh? I like that video. So that's what we have to look forward to in the future. Okay, so let's carry on here. All right. I'm not going to go through this because we saw that in the video. Okay, we mentioned in that very first website about trends, they talked about wide area networks. So just very quickly, there's two major concepts. A local area network is usually a network within a building. So I usually give the example, if any of you have been into the Donald P. Corbett Business Building, that's a local area network. It uses an Ethernet-based system to transmit packets within the building, and then a wide area network is when you put local area networks together. So if I'm requesting a web page outside of DPC, the Donald Corbett Business Building, the address is outside of it. It gets sent out onto the wide area network. Again, the ultimate wide area network is the internet. In one of those videos, you already saw what packets look like and how web pages and other protocol-based things like email get broken down into packets, which then get sent across the networks. But just as a basis of comparison, that's packet switch networks. So they use packets. The old way is this thing right here, circuit switching. The POTS, plain old telephone system, uses a circuit switching system, which is a direct line. So you have to, if I'm calling you, we have a direct connection. It's a circuit switched connection. And so it's limited because if you think about how many direct lines there are, it builds up so quickly, it becomes very expensive. Whereas with packets, you can send them across this mesh, and it's much more efficient. You don't have to use one dedicated line. If that one's busy, you can just send it across the mesh to other lines. I hope that makes sense of why the packet switch mesh network, the internet, is so much more efficient than the old telephone circuit switch system. Okay. And then how it works is that there's things called routers or routing computers. Actually, the packets go to these routers and they examine the packets. Remember in that one video where they showed a picture of the analogy of a package and the label on the package with an address, a to address and a from address. So the idea, these packets all have IP addresses on them. IP addresses just like the post office. The to address, if you're sending a letter to your grandma, you write it to Grandma Jones at 123 Main Street in wherever, Boise, Idaho, or whatever. So the idea is that the internet, the IP address, is the same thing. It's a series of segments which identify where the packets are going. So IP addresses are just like the post office. So you put the to IP address on it. You also put a return address so that if a packet gets lost, another one can be sent. So the analogy is really the same. These little you send a request to Amazon.com. That gets broken up into these little packets. Each of these packets has the to IP address and the from IP address, and it gets sent over to these routers that look at, just like the post office, they look at the IP address and they say, oh, this is going to Oregon. It needs to go off on the internet on these lines, and I'll show you in a second. But very basically, I hope that makes sense. So here's a visual. So let's say this is your computer and you're sending it out to Amazon. The router, the internal router, looks at it and says, is it going within the building, the local area network? Nope, it's not. The IP address is going to Oregon. So it sends it out onto the internet. It goes onto these different routing computers, which examine the packets and say, well, it's got to, let's say from, if I'm in Oregon, if I'm in Orono, let's say it first goes to Bangor, and from Bangor it goes to Portland, and from Portland it goes to Chicago, and so on and so forth, until ultimately it gets to the other site, Amazon.com. Here's another one that's even a better one. So let's pretend that we are University H. This is us here, and then pretend this is the Donald P. Corbett Business Building. This is our local area network. Next door is Scheibel's Hall. That's a different local area network. We could communicate within the local area networks on campus, but again, if we're trying to reach Amazon.com, the router, well, first the internal local area network router looks at it and says, it's not within the building, let's send it out to the peripheral router at the edge of campus. Then we're going to send it out onto the internet. The backbone routers are huge supercomputers. that read the millions, billions of packets and send it. Essentially, the analogy is a superhighway. So the superhighway from Portland to New York to wherever, and then ultimately across the country, where it then gets broken, sent to a smaller router. And let's say this is Amazon here. It goes to their peripheral router and then gets sent to the specific server for the web page that you're looking at. So I hope that makes sense. These packets are just like the post office, and the backbone is kind of like our super highways, which then break off into smaller roads. Okay, a public network is like the internet. A private network is when you restrict access to it. And companies, if you were the company, you can pay for space on the internet and becomes private. A virtual private network, this is important for you to know, because think about the internet, everything is public, packets go everywhere, but if you are working away from the office and you are sending and receiving information that is confidential, the virtual private network is a really interesting thing. So let's say if you're working on your laptop or your smartphone or whatever, there's software that you install on it that will encrypt the data. And essentially what virtual private network does is it creates this encrypted tunnel through the internet until it reaches your destination, which let's say it's your, somewhere in your company, maybe it's your inventory server or, customer information, whatever. But the virtual private network is really cool because this encryption software is on your device, whether again your laptop, your smartphone, whatever, and it's also on the other end. So it encrypts the data, and when it gets to the other end, it decrypts it. When they send information back, it encrypts it, and then when it gets to your device, it decrypts it. So it's a very powerful thing. It's very inexpensive. It might even be free in some examples, but VPNs is something you should definitely know about, especially with a mobile society. Okay, these are two concepts that are also something as a manager you should know about: an intranet and extranet. An intranet is basically, let's say when you log on to, how when you log on to my.umain.edu to get into our UMain portal, that's an intranet, because as a student, or if you work for General Motors, an employee, that gives you access to all the information throughout that you are entitled to see within the university or within your companies. That's an intranet. And an extranet is when you then, for whatever reason, you allow access to your internal system by outsiders. Let me show you. Here's a good visual. So an intranet, documents, collaborating with employees, reports, and so on. An extranet is when you allow outside people to access certain things, certain information. So for example, if you do remote banking, that's an extranet. They give you log in, they give you access to your account information within the company, and lots of other similar examples like that. If you're a supplier and they give you access to some customer demand data so that you can then adjust your production schedule for those orders. That's all extranets. So I think you can see the difference and why extranets also can be very helpful and important. Okay, protocols. We talked about in those videos, we talked about that the internet works because there's a common system of software that's platform neutral, meaning whether you're on an Apple or a PC or any other device, any other system, they all use the same protocols, and protocols are rules that everybody uses to make the system work. So there's a couple of in web, to send web pages, the two common protocols that are platform neutral across all systems are called TCP/IP. And so TCP stands for Transmission Control Protocols, and this is the software that's on every system. So when you type in Amazon.com, it's the TCP software in your system that takes that Amazon.com, breaks it up, it translates it into zeros and ones, and then it breaks it up into little packets. So the TCP software is what breaks that into these packets we talked about. And then when it breaks it up into packets, the second protocol, the IP, which stands for Internet Protocol, is the one that puts the addresses. Remember we talked about the post office analogy? You have a sending address and a return address. It's this software that's on every single device and server and so on that takes each packet and puts the addresses on there so that the routers know what to look for and it knows where to go. And then when it gets to the destination, it lands in the right place because you've put this correct IP address on. When it gets to the destination, the servers at the destination also have this protocol, which then puts the packets together and then looks at your request for a web page. I hope that makes sense. Let me know if you have questions about that, but that's what makes it work. IP addresses, again, as we mentioned, they are the equivalent of addresses you put on letters, except that they are essentially zeros and ones. The old ones were called IP version 4, which meant there were 4 segments, which meant there were a total, if you did the math out for the number of combinations, were a certain number of billions. But with the Internet of Things and mobile devices, we've outgrown that. There's just not enough IP addresses, so we've gone to a new one called IP version 6, which if you do out the math with 6 segments and a certain number of I can't think of the word, factors in each one of those 6 segments, there's, for those mathematicians among you, there's billions and billions and billions of possible combinations. So there's many, many, many more IP addresses. And so what's happening now is all the servers and routers and so on are all switching over to this new IP because we need so many more IP addresses with that explosion in sensors like the Internet of Things and mobile devices and so on. So again, I hope that makes sense. The other thing, just as just for understanding, the Internet itself is the technology infrastructure. So the analogy is, the highway system carries cars. So the highway system itself is the infrastructure. If you live in a city and you've got a water system, the pipes are the infrastructure. That's the analogy to the Internet. It's the infrastructure. They carry the liquids. So the Internet itself is the technology infrastructure. It carries the packets. The packets themselves that go through the wires on the Internet and the wireless, bandwidth, they are different. The packets carry the information. The Internet is the infrastructure that carries the packets. I hope that makes sense. So, and the reason I'm saying that is that there's different protocols for different types of packets. So web packets, as we just said, TCP/IP create web packets that travel through the pipes, the Internet wires. But then email uses different protocols, and the packets for email are different. So it's almost like if the web packets were water and email packets were oil. They're different. They can flow through the same pipes, but the packets are different. And these protocols, the email protocols, create different packets, and they use different protocols. So think about it. When you want to look at a web page, you open a browser. That's different software. When you want to send an email, you open a different software. You open like Gmail, versus if you want to look at a web page, you would open Internet Explorer or Firefox. So it's different software using different packets. Again, I hope that makes sense. Be sure to let me know. We're going to actually talk about client-server architecture later. I'm not going to go into the web because we covered that. I'm not also not going to talk about HTML and CSS because we're doing that, and you know that. The only thing I will say is, so we've been talking about, we are using HTML. I will tell you XML. I'll show you just very quickly what that is. But now the new convergence of XML, HTML is called XHTML. And let me just show you very quickly the basic difference. HTML is what we're using. It's for web pages. XHTML is when you kind of merge XML. XML in a nutshell, and I'll show you this in a second, is where you basically create your own tags. What we're doing, as you probably know by now, you've probably created your web pages, we use pre-formatted HTML tags. We don't make them up. In XML, you can make up any tags you want. You put them inside the little tags, and basically what businesses do is they create libraries of these XML tags. So let's say a purchase order for the steel industry. You would create a standard XML form that everybody will use so that it's consistent, but you make it up yourself. Versus in HTML, you use the standard HTML tags that we're all using. And so when you merge them, essentially it's more strict. XML is much more strict than HTML. But the whole thing about XHTML is that you can then use what's called an XML parser. So let me go back and hopefully this will make sense here. So okay, let me go first to, okay, we've done CSS, you know what that is. So, okay, so XML. All right, so here's an example of HTML. These are what we've been doing. Remember, open head, open body, close body, H1, H2. So you know all that. Okay, so, and it looked like this. Now with XML, you create your own tags. So we make up a tag called country list. We make up a tag called country name, capital city. So we're making up our own tags in XML, and then basically we then put those into a database system and we populate them with the data that we want. So country name, capital city, and so on. And then there's these, here's a good visual. So there's this software called XML parser, and you put the data into an XML database, and then you can pull from the XML database and use this XML parser, the software that pulls out the data that you created and using sort of the equivalent of CSS, but it's an XLS style sheet to format it so it looks nice, and then you send all of that using a web server, and then it can be served up on any device. So XHTML can use this software where just standard HTML uses an HTML processor. So it just makes it more efficient because you can then use the database and pull data from the database into the XML formats that you've created. Okay, again, I hope that makes sense, but in the interest of time, I want to keep moving on. So the internet, remember I mentioned to you a few minutes ago that all of those videos we saw were based on the assumption that we had really great broadband. And I want to show you a couple videos to show you, kind of give you a better understanding and appreciation of broadband. Let's see here. Oh, sorry. Didn't mean to do that. Again, if you don't have broadband, you can't do any of this stuff. So let me show you this little video because it's kind of meaningless to us until we see something like this. This is a great video. I think you'll like this. So what is broadband and why is it important? Okay. So this is your old dial-up connection. And I don't know if you can see that little stream now. This is probably cable. This is what you're getting data. Okay, with cable. And if you upgrade your cable, then if you go up to 15 megs, you can see the data stream is better. And we're going to upgrade to 50. There we go. So you can see if you're transmitting lots of data, especially with the Internet of Things and videos and all kinds of stuff, you're starting to, you need a fast connection. Now here's the gigabit. Watch this. This is cool. All right, that's a very good visual of the difference. If you're streaming video, you need this. So on that, let me then show you this video, which shows you why broadband is so important. And this is, gigabit connections.
Here's our own Christopher Mitchell to break it down.
Essential infrastructure, like roads and bridges and electricity and that sort of thing, they're built with the future in mind.
It's a bewildering future, all right.
They meet our immediate needs now because we've planned for that extra capacity. When I want to use my toaster, I don't have to worry about blowing a fuse. I don't turn off the lights and I don't unplug my fridge. There's more electricity that's flowing into my house than I can use at any given time. And that's how our networks will work in the future. And in fact, they already work that way in Wilson in North Carolina, in Cedar Falls, Iowa, Sandy, Oregon. And the big cable and the telephone companies, they might ask, what application could possibly justify a gig? But that's not how we should think about infrastructure. A single car or truck doesn't need a 3-lane highway. No vehicle is 3 lanes wide. The highways are designed for traffic, many different vehicles. They have to accommodate these different vehicles at the same time. And it's the same thing with our internet infrastructure. No one application needs a gigabit network, but households already have many connected devices, like computers and smartphones, tablets, game consoles, lots of other things. And each year we get new and better devices, and they all demand connectivity, and next year they're going to demand more connectivity. You remember the world with dial-up access? We couldn't stream video. And now that our connectivity is better, streaming video is just a part of life. Our applications get better as our networks get better. It's a sort of chicken and egg problem. But the fact is, we actually need robust infrastructure to have that kind of innovation to begin with. Fast movers like Chattanooga.
Oh, pardon me, boy. Yes, yes. Is that the Chattanooga choo-choo? That's the Chattanooga choo-choo. On track 29.
They're seeing an influx of entrepreneurs. Now, the big cable and telephone companies are all like, okay, all right, here's a gig. But a gig ain't a gig when the upload is 90 or even 97% slower. That's what the big cable guys are doing in particular. They're pretending to offer a gig. We shouldn't accept that. We need to be able to produce big things, and that means we need to upload big things. With cloud services and iPhones recording in 4K video, and we need fast upload speeds, and for that, we need fiber and we need high-capacity wireless networks. Frankly, most of us could get by just fine with a 100 megabit symmetrical connection. But the cost to build that network, they're basically the same as building a gig. So let's think bigger. Don't be fooled.
Okay, so I think that's a really good explanation of why we need, really robust networks. And I hear it a lot in the consulting projects. You may hear it also in yours, that these businesses cannot operate in many places in Maine because they don't have the technology infrastructure. I knew an entrepreneur who moved to Bar Harbor and needed broadband because of his business. It was an online testing service. And Bar Harbor, let's see which is down here, but he lived in town. I think there was a fiber optic network that went to the Jackson Labs, but in the town itself, there was no high speed. So you can see this is the technology, it's called the 3-ring binder, the fiber optic network that goes around Maine. Up here, like this is where Sugarloaf is. Lots of people want to move there. It's a gorgeous area in the mountains, but you can't. How can you run a business? There's nothing here. You can get cable, and you remember he said symmetrical connection of 100 megabits. Symmetrical means downloading and uploading, and that's what he was talking about. In fact, a lot of the cable companies and other broadband providers say, oh yeah, we'll give you 50 or 100 megabit, but that's download. So if you're running a business, you need that speed to upload as well. So most connections that we get are asymmetrical, meaning it's usually faster downloading than uploading, but oftentimes we really need a fast connection. And you cannot run a business if you don't have really robust, fast internet. So as a manager living and working here in Maine, and we, small business and entrepreneurship, it's the lifeblood of Maine. So we really need better technology infrastructure. Okay, I am almost done. Bear with me here. Okay, so let's see here. All right, the last thing is the convergence of the internet and mobile networks and so on, because when you're traveling, you can get the internet through your mobile service with your data plan. Or if you have access to Wi-Fi, then you don't have to use up your data. You can use Wi-Fi, but that's kind of converging. And I just wanted to show you the evolution of mobile networks, because pretty much we're on 4G, which is often called LTE or WiMAX or whatever. And the basic difference between all these generations is usually the bandwidth, the speed, and the capacity for data. And as you know, as they were just saying in those videos, so many more things with the Internet of Things, with artificial intelligence, with so much video and high data traffic, we need faster, better bandwidth. So the evolution is this 5G, and let me go back to, I think this is my very last one. Here's a recent article from PC Magazine, May 1st of 2017, and they talk about 5G. It's coming this year or maybe not. So 5G is more robust connections, much faster, much greater bandwidth. And this is just an interesting article. They just talk about the hype behind this and perhaps a little bit of deception. AT&T talked about its 5G network, which isn't 5G. It's an incremental. It's a little bit faster than 4G, but it's not quite yet the robustness and the speed and capacity of a true 5G. But anyway, you might want to look at it. I don't want to spend too much time, but let's see. They're working on it. The Verizons, the AT&Ts, they're working on it, but it's a huge investment to build these towers and the infrastructure to support this much greater speed and bandwidth capacity. But that's what's coming, the 5G, which really, if you think about what we talked about earlier, the Internet of Things, is what we're going to need. And our technology infrastructure is going to have to keep evolving and becoming faster and covering more places to support the growth of and the need for huge bandwidth. With that trend towards everything becoming cloud-based, you can envision that we really need a very robust, seamless, high broadband, fast connection to support all of that, to enable really good e-commerce and e-business. So, okay, on that note, I'm going to close out here, and I look forward to seeing your thoughts and comments in our discussion forum. Thank you.